Welcome to the Basic Warewash Training course, AutoClaw Services e-learning online classes. In this module, we will learn about using multimeters. A multimeter is the instrument used to read voltage of alternating current and direct current. It may also be used to read ohms or continuity. Precautions for personal and instrument protection. Read the instructions of your multimeter thoroughly and follow them carefully. In many instances, you'll be working with dangerous levels of voltage and/or current. Therefore, it is important that you avoid direct contact with any uninsulated current-carrying sources. Safety glasses are to be worn. Before connecting or disconnecting the meter to and from the circuit to be tested, turn off all power to the circuit. Before applying test leads to circuit under test, make certain that leads are plugged in to the proper jacks and switches are set to the proper range and function. Before using any electrical instruments or tester for actual testing, the unit should be checked on a source that is working. Do not use power distribution lines or any other high energy sources. If the instrument should indicate that voltage is not present in the circuit, do not touch the circuit until you have checked to see that all instrument switches are in proper position and the instrument has been checked on a known live wire. Make certain no voltage is present in a circuit before connecting ohm meter to a circuit. Plug in only one accessory probe or the set of test leads at any time except as directed. Failure to follow these instructions and/or observe the above precautions may result in personal injury and/or damage to the instrument or accessories. Electricity is not something that you need to be afraid of, but we should respect. Remember, we can't see electricity. The importance of understanding how to use a multimeter. A multimeter is a device used to measure voltage, resistance, and current in electronics and electrical equipment. It is also used to test continuity between 2 points to verify if there are any breaks in a circuit or a line. There are two different styles of multimeters, analog and digital. Analog has a needle style gauge. Digital has an LCD display. A switch multimeter is manually switched between ranges to get the most accurate reading. Auto range switches between value ranges automatically for best reading. Both of these are switched manually between function settings and measure the same way. During this course, we will be using the ideal 61746 multimeter as examples. Getting to know your meter is very important. Read the instructions of the meter type that you have to make sure that you understand how the functions work and how to use it properly. The red meter lead is connected to the voltage resistance or amperage port and is considered the positive connection. The probes are the handles used to hold the tip onto the connection being tested. The tips are at the end of the probe and provide the connection point. The black meter lead is connected to the common or ground port and is considered the negative connection. Understanding the display and the dial settings, this is a jaw clamp. Jaw clamps are generally used for testing amperage. A data hold feature, the function dial. This is the range button, the LCD display, the positive and the negative terminal ports to plug in your leads, non-contacting voltage button, the measuring functions of which you use the function dial to set your measurements, and the lever for opening and closing your jaw clamp. To understand a little about these meters, first we have the auto manual ranging mode. This meter defaults to auto ranging mode when powered on. In this mode, the meter automatically selects the best range to display the measurement. By pressing the range button on the meter, the manual range mode will override the auto ranging feature of the meter. A bullseye appears in the upper left side of the display. Continue pressing the range button until the desired range is obtained. Use this mode to lock in a specific range for repeated measurements. To return to the auto ranging mode, either press the range button for greater than 1 second or turn the meter off and then back on again. Data hold feature. Press the hold button on the side of the meter to toggle in and out of data hold mode. Hold appears in the upper left of the meter display when the data hold is active. Use the data hold feature to lock a measurement reading on the display. Press the hold button again to unlock the display and obtain a real-time reading. Power off. The meter automatically powers itself down after 10 minutes of no use. Press any button and the meter will wake up and display the last reading taken before power down. This feature can be overridden by holding the range button while turning the function switch from off to any other position. When auto power is defeated, the APO will be removed from the display. Turning the meter off will restore the APO default. The display. There's the count display to show your readings. If you are testing for amps, an A will show. If you're testing for voltage, a V will show. If you're testing for ohms, the ohm symbol will display. This unit has other functions of measurements that we don't actually use in our line of work. These are for use for testing electronics. It also has a low battery indicator. It shows whether you're testing for DC voltage or AC voltage. This is where the range feature shows up. If you press the data hold button, the auto power off will display here, or if you're testing for audible continuity, you will show at this corner. Some other symbols to familiarize yourself with. A sideways backward S is considered AC voltage. A line with 3 dashes underneath it is considered DC voltage. A positive symbol, the negative symbol, an ohm symbol, an auto continuity symbol. These are the main symbols to be familiar with. Measuring voltage. Voltage is the unit of electrical pressure. 1 volt is equal to the potential difference needed to cause 1 amp of current to pass through 1 ohm of resistance. It is the force that pushes the electrons through a wire. Voltage is broken up into 2 sections, AC and DC. Alternating current is house or business voltage, 110 to 240 volts. Direct current is battery voltage, 12 to 24 volts. On switched meters, use one value higher than expected value. Be careful not to touch any electric components within the equipment and do not touch the tips to each other while connected to anything else. To measure voltage, connect the leads in parallel between 2 points where the measurement is to be made. The multimeter provides a parallel pathway so that it needs to be of a high resistance to allow as little current flow through it as possible. In our business, we use the terms of low voltage and high voltage for alternating current. Low voltage is under 200 volts. High voltage is considered 200 volts or higher. When testing alternating current, we set our meter to voltage AC. We use our meter leads to connect our circuit. Here we're testing 208 single phase. Because our circuit is running through fuses, we test the opposite side of our fuses to ensure that our current is flowing through. To test low voltage out of a transformer, we would put 1 meter lead on the voltage or the hot leg, the 2nd meter lead on a common. When testing low voltage in our dish machines, connecting to a white wire anywhere in the machine will complete the circuit. If you are testing each individual leg on hot voltage, 1 meter lead goes to ground and 1 to a hot leg. Test the 2nd hot leg to ensure that we have the correct voltage. To test voltage on DC or direct current, set the meter lead to direct current voltage. Set 1 meter lead to one point and your next meter lead to another on a battery. You'll notice that the negative sign has popped up above the DC display. This shows that your positive meter lead from your meter is on the negative terminal of the battery. If we switch our meter leads, you'll notice that the negative goes away and it shows that your positive terminal is on the positive connection of the battery. Another test for direct current, this would be in our dispensers. If a motor is not running, we take our meter, we put it on direct current, and we test the positive and negative terminals coming off the circuit board to check, to verify, do we have correct power running through? If we have correct power coming through, we can now test the connections next to the motor to verify, do we have the right voltage coming through? If the current is not coming through the wires to the motor, then we have a break in our wires. If the correct voltage is coming through the wires and the motor is not turning on, you have a bad motor. Next, let's talk about switches. Normally open and normally closed describes the state or position of contacts in a switch. Switch contacts can be open or closed. Closed contacts can conduct current through the switch, while open contacts cannot conduct current. The switch can have multiple sets of contacts. So some contacts can be normally closed, while others are normally open on the same switch. Normally closed contacts will be closed when the spring is in its more relaxed or resting position. The contacts will open only when something, such as a solenoid or other mechanical force, causes the contact to move from their resting position. Normally open contacts work the other way. They are normally open when the spring is in a more relaxed position and close only when the switch is forced to its other position. The switch will always return to its resting position when the mechanical force is removed. Note that this is not true on non-energized state is normally open. The non-energized or resting state can either be normally closed or open, depending on the design of the switch. And as we mentioned earlier, many switches come with one set of contacts normally open and another set of contacts normally closed. A closed circuit is one that allows current to flow. An open circuit is one that does not. Let's show how this works on a single pole switch. We have current flowing through on the left side. We take one of our meter leads, we set it to AC current. One goes on the switch where the current's coming in, and a negative to our common or our neutral pole. And again, remember, you can connect to any white wire in the machine to grab a common. This shows our voltage coming through. We now put our meter leads on the switch. This is the wrong way to test a switch. When testing a switch for current running through it, we take one of our meter leads and put it back on a common or a neutral post, and one to the opposite side of the switch to see, do we have current flowing through the switch? Let's take a look at a two-pole switch. In our line of work, we use a lot of switches that can operate two different devices. To test the two-pole switch correctly, we put our meter lead on the power coming into the switch and our second meter lead on a common or neutral post. When we close the switch to one side, we move our meter lead to the discharge side of the switch and one to common to ensure that we have power that runs through the switch. When taking the second, we move our meter lead to the second contact to ensure that it is working properly. Let's take a look at a micro switch. Micro switches are very common in our line of work. To be able to test a micro switch while it's connected to voltage, we put one of our meter leads on the intake side of the power and one on a common, again using a neutral post or any white wire that you find in the system will complete the circuit. On a micro switch, you have a normally open and a normally closed circuit. So while it's in its resting position, we can move our meter lead to the normally closed circuit to verify that we have power coming out. If the micro switch has a force against it, or as a Kramer timer is turning, the switch changes positions. We now lose power to the normally closed. We can move our meter lead to the normally open, where power is going to it. Remember, when force is removed, then the switch goes back to its normal resting position, and in this case would be a normally closed circuit. Let's take a look at one more example of a reed switch. This would be the example of a reed switch that's on a conveyor. When testing a reed switch, we would attach the meter lead to the discharge side of the reed switch and to a common. It would show that the switch is closed. This is when the magnet has been removed. Remember, on a conveyor, when you put a rack in, it activates the sequence bar and it removes the magnet from atop the reed switch. That allows the switch to go its normal resting position and the switch will close. As the sequence bar is coming in and out from racks coming through it, it opens or closes the switch. So again, as we've seen in the first reference, when the magnet is away from the reed switch, the switch is in a normal closed position. When there are no racks in the machine, the magnet is straight over the top of the reed switch, which forces the switch to open. Therefore, no voltage is transferred through the switch. Next, in using a multimeter, let's talk about measuring resistance and continuity. This part of our electrical work is actually very important. This allows you to know whether a switch or a contact is working or not working. Here we actually become troubleshooters and not part changers. Continuity refers to being part of a complete or connected circuit. Continuity test is checking an electric circuit to see if current flows through it. Resistance is the opposition to current. Resistance is measured in ohms. Before testing for continuity, shut the power off to the source and verify there is no power to the machine or device before testing. Remove component or disconnect from the system before testing. Set the multimeter to test for ohms, or if using audible continuity, set your meter to audible continuity setting. Audible continuity allows you to hear a beep if the circuit is complete. Place the red and black terminals on the component you are testing. You should see a minimum resistance of 0.1 ohms to 1 ohm present or hear the audible beep. If there is no reading or see an O.L on the display, or the circuit is broke and not working. Let's look at examples of testing continuity. Let's set our voltmeter to ohms. And to remove the component from the circuit so that we can test, we're going to test a fuse. In this case, it's showing that the fuse is good. If the fuse was not good, it would continue to show the OL on the display. To test continuity on a single pole switch, again, we turn power off to the system. You would remove your wiring from the device or the switch that you wish to test. Set your voltmeter to read ohms or to audible continuity. Place your meter leads between the connections, and this shows that you have a complete connection and the circuit is good. This tells you that your switch is working. Let's run a continuity test on a micro switch. Again, the test runs in the same manner. We would take 1 meter lead to the incoming source and 1 meter lead out to the normally closed. In this case, it's showing that the switch is a full contact and that the switch is working. If we move the switch to the normally open side, we take our meter lead, we move to the normally open, and we verify that it also has contact and that the switch is working correctly. Let's run one more example of testing continuity. Let's go back to the reed switch on a conveyor. As you notice, as the magnet is away or if a rack is running through and the sequence bar removes the magnet on top of the switch is in the normally closed position. To test continuity, disconnect the reed switch from the wiring on the system. Again, always verify there is no power to the system. Adjust your voltmeter to read for ohms. Connect your terminals to each end of the reed switch to test for continuity to see if the switch is closed. To verify if the switch is working properly, you can activate the sequence bar to open and close the switch to see if the switch turns on and turns off. This is a very simple way without removing the switch from the machine to verify whether it's working or not working for you. Measuring current. An ampere is a unit used to measure electric current. The bigger the current, the more electricity is flowing. Check the data plate to determine the maximum amps of the device you are testing. On all machines or motors, there should be a data plate that will show you what the amps should be. On this particular motor, it can be wired for low voltage or high voltage. This particular motor runs low voltage, and it would max out at 12.2 amps. Set the multimeter to amps or the A with the sideways squiggly line. If the multimeter is not an auto ranging unit, select the next setting higher than listed on the data plate. Open up the clamp and place around one of the wires connected to the load to be tested. Take note, you can only test one wire at a time. If you are testing a three-phase load, you will test all three wires separately. All three wires should be no greater than an amperage displayed on the data plate. Turn on the device to be tested. Amps can only be tested while the load is running or operating. For example, a motor has to be on, the heating element has to be heating up, and etc. Only the way to test amperage is while a load is actually consuming current. Also keep in mind, when you're checking your amperage max load, once the amperage starts exceeding that, you're starting to have a couple of problems. One is either the motor, the heating elements are starting to go bad, or you have loose wires. Any loose connections can cause a load to try to draw more current through, which would cause the amperage to increase. If this went on for any length of time, the wires start heating up, they start becoming more loose, and eventually can either break or burn. Again, correct connections for using amps. If you're testing amperage, again, your meter, your jaw clamp would go around one wire at a time. Putting it around two wires is an incorrect, and you will not get a correct reading. To recap, a meter capable of checking for voltage, current, and resistance is called a multimeter. When measuring voltage, the multimeter must be connected to 2 points in a circuit in order to obtain a good reading. Be careful not to touch bare probe tips together while measuring voltage. This will create a short circuit. Never read resistance or test for continuity with a multimeter on a circuit that is energized. Remember to turn the power off and disconnect the circuit. When measuring current or amps, the multimeter must be connected in a circuit so that the electrons have to flow through the meter. In other words, one wire at a time. Learn more about using multimeters by talking to your managers, regional manager, or vice president, or contact the training center for more information.